Welcome back to Astronomy. This is Chapter 8, Formation of the Solar System. In Chapter 7, you learned about the solar system. Now we're going to look at how the solar system came to be the way it is from its earliest formation. And in this video, Part 1, we're going to look at the nebular theory. First question is, what properties of our solar system must a formation theory explain? As we look at our solar system and all its properties, scientists are interested in knowing how it came to be the way it is. So as we look at the properties that you studied in Chapter 7, we want to think about how did it get this way? One property we want to look at is the patterns of motion of the large bodies. And I want you to remember that as we think about the planets in the solar system, they all go around the sun in the same direction. They're in approximately a plane. We call that the ecliptic plane. And they all go around in that same counterclockwise direction. Not only that, but the sun rotates in that same direction. The asteroids in the asteroid belt go in that same direction. Most of the planets rotate in that counterclockwise direction, and most of the large moons in the solar system go around in that same counterclockwise direction. Now, this can't be random that they all are going in the same direction. There's a commonality there. And so a good theory that explains the origins of our solar system should give an explanation to why they all go around in that same counterclockwise direction. Also, a good theory should explain the existence of the two types of planets. So remember, there are terrestrial planets, Mercury, Venus, Earth, and Mars, and there are Jovian planets, Jupiter, Saturn, Uranus, and Neptune. And they're very different types of planets. Terrestrial planets have the solid surfaces. Jovian planets are mostly gas. And a good theory should explain the existence of those two types of planets. A theory of the solar system's formation should explain the existence of the smaller bodies, asteroids, and comets. And it should explain notable exceptions to the usual patterns, such as even though I said most planets rotate in that same counterclockwise direction, rotating on their axis, remember that Uranus is tilted on its side at about a 98-degree angle. Venus is upside down. So a good theory should explain why those are different. It should explain why Earth has a relatively large moon. Generally, what we see is that the smaller planets have few, if any, moons, and the moons they do have are small. Mars has very small moons, and we don't expect that a planet like Earth should attract a very large moon. So the question is, why does it have such a large moon? Other exceptions not shown on this slide, but while I mentioned that the planets in the asteroid belt, I can throw in there the Kuiper belt, they all go around roughly in the same plane around the sun. Some things do not, such as the Oort cloud of comets. We'll talk more about it in Chapter 12. Those comets do not go in the same plane. The nebular theory states that our solar system formed from the gravitational collapse of a giant interstellar gas cloud, which is known as the solar nebula. The word nebula is the Latin word for cloud. And when you see this word interstellar, inter is from the Latin meaning between, stellar means stars. So it just means between or among the stars. At one point in time, there was a large cloud of gas, and it gravitationally collapsed and eventually formed our sun and planets. That's the theory. Now, this was proposed in the late 1700s by Immanuel Kant. He proposed what's known as the nebular hypothesis. And it's exactly what I just said, that the theory is that our solar system formed from a cloud of gas that collapsed. And there is now a large amount of evidence that supports this idea. So it has gone from being a hypothesis over 2 centuries ago to being a theory because it stood up to rigorous testing of observation. Where did the solar system come from? This picture is of a nebula. It's been called the pillars of creation, and it's a place where we see stars being formed. In fact, a general term for a cloud like this is called a stellar nursery, where stars are being born. And we think that it's some cloud like this, a large cloud, many, many light years large, that our solar system originally formed from. I want to teach you about what's called the star-gas-star cycle. The idea is that you can think of the galaxy, or any galaxy, as a recycling plant for stellar material. This is galactic recycling. Elements that formed the planets were made inside stars and then recycled through interstellar space. So here it has stars produce heavier elements from lighter ones. When stars die, they return the material to space. Stars are born in the clouds that came from that material that got returned to space. So when it got returned to space, it became a cloud, and then new stars are formed. Let's look at the first part of that cycle. All elements besides hydrogen and helium were formed inside stars. We believe that in the very beginning of the universe, there was originally hydrogen and helium, but no other elements. And all elements beyond hydrogen and helium have been formed inside previous generations of stars. The second part of the cycle. Stars return the material to space when they die. When we get into the unit on stars, that's chapters 15 through 18, we'll look at the life cycle of stars. And we see that when a star runs through its fuel and it eventually burns all its fuel, essentially, we say it dies, and it puts much of its material out into space. Now, while it was a living star with nuclear fusion, it was producing heavier and heavier elements. So those heavier elements get returned into the galaxy, or they get put out into the galaxy. And the third part of the cycle is that of those clouds of gas that are put out from stars, new stars can form. So this is what's known as the star-gas-star cycle. Your atoms were made inside stars. So as you look around you, all the things you see, very little that you see as you look around you is hydrogen or helium, especially not helium. Hydrogen is a major component of water, but so is oxygen. Most everything as you look around you is not hydrogen or helium. All of these atoms were originally formed inside stars. And again, when we get to the unit on stars, particularly the life cycle of stars in chapter 17 and the death of stars in chapter 18, you'll see the processes by which heavier elements are created inside stars and then exploded out into the galaxy. We can see stars forming in other interstellar gas clouds, giving support to the nebular theory. This picture that you see, that this video started with and now ending with, is a picture many light years away of a star system that's being formed. So what you see is the hot center, which is what we call a protostar, and around it is a disk, and the gaps in the disk are where we think planets are forming. So this is a picture of what we think our solar system once was. It's interesting to note that this picture is a relatively recent picture, and before we had photographs like this, we would have our theory of how our solar system formed, how star systems formed, and we would have in the textbook an artist's conception, maybe a painting. And it's interesting to note that the paintings that we used to show students look a lot like the photographs that now we have. Well, that's the end of part one, the nebular theory. Have a great day.